Right, in chapter 10 so far, we've talked a lot about radicals. We've talked about simplifying radicals, multiplying radicals, dividing radicals, and even changing rational exponents into radicals. Now let's talk a little bit more about operations with radicals, maybe adding or subtracting, a little bit more multiplying and dividing, other types of things with radicals. What we're going to start with in 10.5 is adding and subtracting radicals. Now, when we're adding and subtracting radicals, we have to be able to combine like terms only. We've done this before with algebra. Remember, if we have a 3x plus a 5x, as long as they have the same variable with the same exponent, we should be able to combine those like terms and really say that we have 8x. 3x plus 5x is 8x because those are like terms. But if I have 3x plus 4y, because I don't have the same variable with the same exponent, those are not like terms. We wouldn't be able to put those together, so we would just have to leave it, 3x plus 4y. Same idea with radicals. They have to be the same radical with the same radicand in order to be able to add or subtract them together. For example, if I have 3 rad 2's plus 5 rad 2's, I could really say that I just have 8 rad 2's. I can add their coefficients but keep the radical the same. But if I have 3 rad 2 plus 5 rad 3, because these radicands aren't the same, they're not like terms, that's kind of like having an x and a y, I wouldn't be able to add them together, I would just have to leave it as is. Let's practice some more of those. Example number 1 asks us to simplify by combining like radicals. In A, we have 6 rad 5 plus 2 rad 5. Well, 6 rad 5 plus 2 rad 5, because they're the same exact radical with radicand, we can add them together and say that we really have 8 rad 5. You notice that I didn't say 8 rad 10 or 8 rad 25, right? All right, look at B. B, some of those radicals look a little bit different than each other, so we have to be careful. They have to be the same exact radical with the same exact stuff underneath in order to be able to be called like terms and be combined. So if you look, I have square root of 7's and I have 4th root of 11's. Each one of those are like terms to each other. So 5 square root of 7 plus 1 square root of 7 would be like terms. So I could really say that I have 6 rad 7. And if I have a negative 8 4th root of 11 plus 9 times the 4th root of 11, I really have 1 4th root of 11. Again, you can put the 1 there if you'd like to, or you can just leave it as it is. But a rad 7 and a 4th root of 11 are not the same thing, so that would be my final answer. All right, look at C. C says we have 4 times the 4th root of t minus the 4th root, minus 1, I guess you could say, right? Minus 1 times the 4th root of t. As long as my radicals are the same exact radical, then I should be able to subtract these. So I can subtract their coefficients, 1 minus 4, and I could really say that I have 3 times the 4th root of t. All right, look at D. Be careful here. On D, I have the cube root of 2. I also have another cube root of 2, and I also have another cube root of 2. It looks like all of those have the same exact radical. I should be able to add their coefficients together, but here's where you have to be careful. If you look at the first term here, we have a 1 times the cube root of 2, and then over here I have 5 times the cube root of 2. 1 plus 5, I can really call that 6, right? But if you look at this middle one, it has a 7x. So if I have 6 minus a 7x, I really wouldn't be able to put those together any more than they already are, and I can't really make that a negative 1 or a 13, right? And so when I combine these, I've got to be careful of how I write it. I can combine the 1 and the 5 and call it a 6, but then I really have a minus 7x also there in front of the radical, so it's important that I use parentheses to symbolize that my coefficient is the whole thing, 6 minus 7x, and the whole thing is being still multiplied by a cube root of 2. Be careful, there's an x there that makes it so that you can't combine the 6 and the 7, and then make sure that you use your parentheses there. All right, let's do a little bit more because sometimes we might have to simplify our radical first before we can combine like terms. So let's use some of our techniques that we've used in a previous section to help us do that. Let me show you a few examples. Look at example number 2 with me. It says simplify by combining like radical terms if possible. Well, if you notice, I have a 9 rad 50 minus a 4 rad 2. Well, the square root of 50 and the square root of 2 are not the same thing. But it doesn't mean I can't do anything with this problem. Maybe it just means I have to simplify first. So let's look at the square root of 50 and let's see if we can factor tree, break it down, or simplify it. I'm going to think of factors that multiply to 50. I said 5 and 10. Then I factored 10 into 5 and 2. I'm looking for groups of 2, remember, because this is a square root. So it looks like I can bring out that group of 5, and then I have a lonely 2 inside. Don't forget you also have that 9 that's still in front. So you have a 9 in front. You also have a 5 outside. Remember, we multiply those together, and then we have the lonely 2 on the inside. So I really have 45 rad 2 minus 4 rad 2. Oh, look at that. They are like terms. Now they both have rad 2's in them, and since they both have the same radical, I should be able to subtract their coefficients and combine these like terms. So 45 rad 2 minus 4 rad 2 is really 41 rad 2. But I didn't know that until I simplified that radical, right? All right, look at B. I have 9 rad 6 minus 4 rad 3. Well, square root of 6 and square root of 3 aren't the same thing. So let's try to simplify. Well, if you look at square root of 6, I can factor it into 2 and 3. Unfortunately, those are my only prime numbers, and I don't have groups, partners, pairs of 2, right? So the square root of 6 actually can't be broken down. The square root of 3 can't be broken down. And so it looks like these are never going to be like terms, and so I wouldn't be able to add or subtract these together. I would just have to leave it 9 rad 6 minus 4 rad 3. All right, look at C with me. C has a few different variables in here. It looks like we have an x here, right? An x and an x to the 4th. I have the cube root of 54x minus the cube root of 2x to the 4th. Not the same thing, right? They're both underneath the cube root, but underneath are very different. Unless we can simplify or break them down into the same thing, and then they happen to be like terms. Let's try. Breaking down 54, I broke down 54 into 9 and 6. I then broke down my 9 into 3 and 3, and I broke my 6 down into 2 and 3. Remember that we're looking for groups of 3 this time because we have a cube root, so I notice that I have 3 3's. The 3's can come outside, and then I have a lonely 2 that stays on the inside. So it looks like this one breaks down into 3 times the cube root of 2, and then remember there's an x still inside that doesn't have any partners to come out. So I have 3 times the cube root of 2x. All right, look at the next term. I have a 2 underneath there. Doesn't have any friends, doesn't have any partners, so the 2 can't come out. It has to stay inside. But I do have 4 x's, and if I'm looking for groups of 3, it looks like I can bring out one group of x's, and then I have a lonely x that's inside. So my second term reduces to a negative x times the cube root of 2x. What do you know? Those radicals are the exact same thing. They're both cube root of 2x's. So I should be able to combine them by adding their coefficients. Now be careful. I have a 3 and a minus x. Because those don't both have x's in them, they're not like terms. I can still combine these radicals, but I have to be careful with how I write it. My coefficient is really 3 minus x, and it's all connected to that not square root, but cube root of 2x. So it's important that you put parentheses. This would not be the correct answer because to me this looks like it's only attached to the x and not the 3. So it's important that you put that coefficient in parentheses so that the whole thing represents the coefficient that's being multiplied by that cube root of 2x.